welcome back to my YouTube channel, Engineer Cinco from CLNP. Today guys, we have a new subject related to solid mensuration. And by the way, our first topic regarding this solid geometry is related to cubes. So guys, what do you mean by cubes? Is it's a type of box, okay? Cube is like a box having all equal sides, okay? So this is a cube. It's like a box having the same sides, okay? All the sides are equal. So what are the properties of cube? Our objective regarding this geometry is to find the area, total surface area of a cube. So the total surface area of a cube is equal to 6 times a squared, okay? A squared times the 6 means 6 sides. So how many sides in a cube? Okay, we have 6 sides, right? Okay, this one, 1, 2, 3, 4, 5, 6. Okay, so there are 6 sides. So this is the total surface area of a cube. Now, another one what we are going to discuss is regarding the volume. Volume of a cube, okay, is equal to a cube. So this is the formula for the volume of a cube. Any sides, which is a to the power 3. And the third we need to find is the diagonal of a cube, okay? So if this is the cube, this is the diagonal, okay? Okay, this one. Internal diagonal. Okay? Internal diagonal of a cube, which is equal to a times square root of 3. Okay? So remember guys, these are the formula to find the surface area of a cube, okay? This one is equal to 6a squared. Remember also the formula to how to find the volume of a cube, okay? It is a to the cube. And the diagonal, okay? The length of this diagonal, maybe this one, this diagonal, or this one, okay? So this is the formula for solid geometry regarding a cube, okay? Now I'm giving you some example word problem related to this particular solid geometry for a cube, okay? In order to understand further. So, okay, the problem states here that the total surface area, okay, of a cube is 864 square inches, okay? 864 square inches. Okay? Find the volume of the cube, the first requirement. And second requirement is find the length of a diagonal of one face of the cube. What do you mean by this diagonal of one face, guys? So this is the one face of a cube, okay? This one. So we need to find the diagonal length, okay? This one. Okay? This one side of a cube. One side face of a cube, okay? Find the diagonal of one side face of a cube. So this is this one, guys, the length, okay? And the third requirement we have here is to find the length of the diagonal of the cube. Meaning to say, the internal diagonal of a cube. This one, guys, okay? This one. Okay? Now, solution. A, first requirement, solving for volume, okay? Volume. Volume of a cube, okay? How you will solve the volume of a cube, guys, related to this problem? Take note that the area of a cube is given. Okay, this one. So what is the formula for the area? This one, guys. 6 times a squared. Okay. So total area is equal to 6a squared. Why we need to solve first why we need to use this formula first? Because we need to find the length of the sides in order to find the volume of a cube, right? Because the formula for the volume of a cube is equal to e to the power 3. So we need to find the sides, the length of the side. That's why you need to equate the total surface area to the formula of 6a squared. How much the total area? 864. Okay, 864 square inches is equal to 6a squared. Okay, now to simplify this expression, over 6, okay, cancel. So how much this one, guys? Let me calculate. 864, okay, 864 divided by 6. How much? 144. Okay, 144. Okay, it's equal to a squared. Right? Now again, to simplify, please take the square root. Okay, cancel. So a will be, how much is the square root of 144? It's equal to 12 inches. So the length of the side of this particular cube is equal to 12 inches. A is equal to 12 inches. And also here 12 inches. Anywhere. Okay, A is equal to 12 inches. Now we have already calculated the value of A, the dimension of a cube. Now we can solve for the volume. Therefore, volume is equal to A cube. Okay, is equal to how much A? 12 inches. Okay, power 3. So volume will be is equal to how much, guys? 12 cube, or 12 to the power 3. Okay, 12. 1,728. 1,728 cubic inches. Okay, so this is the volume of a cube for the first requirement. Okay, so 1,728 cubic inches. Okay, now the second requirement in this problem is find the length of a diagonal of one face, meaning one side of the cube. Okay, so B, solving for diagonal or diagonal. Okay, solving for diagonal. Shall we say this is D prime? Okay, D prime. We call it D prime. Okay, this one. Okay, D prime, one face. Solving for diagonal of one face. One face of the cube. Okay. So we will write the diagram here. If this is one face of the cube, so it will be square. Okay. Now if this is the diagonal, D1. D prime, sorry. So, how much is this length? Knowing this dimension, A. A is equal to how much A? 12 inches. Okay. And this one A. So how much D prime? Take note guys, as you can see, this will form as a right triangle, okay? Since it is 90 degrees here. It's a right triangle. As we studied earlier, we can apply principle of Pythagorean Theorem related to this right triangle. So, using Pythagorean Theorem, okay, the equation for this particular diagram, okay guys, is equal to D prime is equal to A times the square root of 2. Right? Based on this diagram. Why it is E to the square root of 2? Okay guys, as you can see here, okay, if it is a triangle, okay, this is the D prime, this is A, and this is A. Okay, if you simplify this one, become to D prime squared is equal to A squared plus B squared plus A squared. Okay, so taking the square root, okay, so D prime is equal to square root of A squared plus A squared is equal to 2A squared. Okay, so what is the square root of A squared? So D prime is equal to square root of A squared is equal to A times the square root of 2. See guys, how to derive this formula based on this Pythagorean principle. So the diagonal equation for this particular cube and in a single face, one face of the cube is equal to A times the square root of 2. Okay, so substitute how much the value of A in this problem? 12 inches. Okay, times square root of 2 is equal to, okay, we need to calculate guys, D prime square root of 2 square root of 2 times 12 inches is equal to 16. Okay, 16.97 inches. Okay, so this is the length or the diagonal length of one face of the cube. Okay, now the third requirement here is the length of the diagonal of the cube, meaning this one, the interior diagonal of the cube. So what is the formula as we study here? The length of the diagonal for the internal of the cube is equal to A times the square root of 3. Okay, so let me erase this one guys somewhere here. Okay, C is equal to solving for diagonal of the cube. Okay, solving for diagonal of cube. This one, guys, D. So, as we all know, the equation for the diagonal of the cube is equal to A square root of 3. Okay. So, substitute the value of A. How much? We have 12 inches. Okay. So, 12 inches times square root of 3. So, D is equal to how much, guys? Okay. Square root of 3 times 12 inches is equal to 20.78 inches. Okay. So this is the value of the diagonal of the cube. Okay. So guys, I hope you understand our topic regarding cube from a solid mensurations. So I will give you another example word problem related to a cube. Okay. The next problem. Guys, we're back. As I mentioned earlier, I'm giving you another example word problem related to the cube geometry. Okay, problem number 2 states that the diagonal of one cube is twice the diagonal of another cube. Okay, find the ratio of their volumes. Okay, guys. So let me draw the diagram. First cube. Okay. Sorry. Okay. This will be D1. Okay. Bigger cube. Bigger cube. Okay. The other one, okay. D2. Okay. Smaller cube. Okay. So this is a bigger cube and a small cube. Because what we are going to discuss here is to find the ratio of their volumes. Okay. So ratio of volume. Okay. Solution, guys. Our requirement is V1 over V2. Okay. So what is the volume? Since the condition for this particular problem is the diagonal of one cube is twice the diagonal of another cube. So the D1, the diagonal of this cube, okay, since D1, the diagonal of this cube is equal to twice the diagonal of another cube, which is D2. Okay. So this is the condition, guys. Okay. Now to solve for B1 is equal to, okay, the volume of cube is equal to, this is A, okay, this is A, this also is A, and this is A, is equal to, volume is equal to A to the power cube, right? Okay. So it's equal to square root of 3 times d1, okay, cube over 9. Okay, it's equal to square root of 3 times what is d1 here in this condition? D1 is equal to 2d2. Okay, 2d2 to the power 3 over 9. Okay, and for v2, okay guys, for v2 is equal to square root of 3 times d2 cube, okay, over 9. Now, we will substitute these values, okay, and these values to this expression ratio. Therefore, b1 over b2, okay, so b1 over b2 is equal to, how much is b1 here? Square root of 3 times, okay, 2d2, okay, 2d2, yes, okay, cube over 9 all over square root of 3 times d2 cube, okay, over 9. So to simplify further this expression, okay, is equal to square root of 3, okay, 2 to the power cube, 2 times 2, 4, 4 times 2, 8, okay, this will be times 8 d2 cube, okay, over 9, okay, okay, all over, how much? Square root of 3 times d2 cube over 9. Okay. Now to simplify further this expression is equal to square root of 3 times 8 d2 cube over 9. You need to reciprocate, okay? Reciprocate the denominator, okay? Times 9. Solve further this expression, we need to reciprocate the denominator, okay? So, reciprocal of the denominator is equal to 9 over square root of 3 times d2 cube. Okay? So, cancel 9, cancel square root of 3, okay? Cancel d2 cube. So, the remaining is 8 is equal to v1 over v2 is equal to 8. So this is the ratio of the volume. You understand, guys? The diagonal of one cube is twice the diagonal of another cube. Find the ratio of their volumes. So volume over bigger volume over smaller volume is equal to 8. So the ratio of between the two volumes is equal to 8. So again, guys, I hope you understand this problem related to the cube geometry. I'm hoping also that it will be helpful those students who are studying solid mensuration, especially in college and even in high school. So again, guys, thank you for watching and have a nice day.